Hello, friends. With our SageMaker model fully trained, it's time to put it to the test. We'll fit the model to new data and thoroughly examine its performance. Get ready to witness the power of SageMaker in action as we fine-tune and evaluate our model for real-world applications. Let's start.
So welcome back. So in last tutorial we have seen that by putting all these hyperparameters and different variables we can define our estimator, and then we can start fitting. Now we can see that our training job is complete, and here we can see that if you come here and you can see the error is like somewhere around is 0.34. It's not too bad, not too good. I mean, when we increase different instance, like we have used, if you remember here we have used iteration was somewhere around 50. If you increase that, you'll see some improvement. You can play with the parameter and you can definitely see some improvement and change, but time being, just for demonstration purpose, our model is trained. Okay, now another thing where we can see that training job is complete. Training seconds was 112, billing seconds 55. Remember, it is all going in our bill. Okay, managed spot training saving 50.9%. So the spot instances, they're always useful. Now we have to deploy this model. Now deployment, it will create endpoints. So let us deploy this model. Okay, and just run the cell. Okay, so here we can see that it is creating endpoint. So it will take some time to create endpoint. So what that this endpoints are? So these are very valuable thing in SageMaker training. So endpoints, they are used when you want to get inferences in real time. So what it means? It means that model has already been trained. Okay, so if it is still in service, then this endpoint will give us bill. Okay, so we need to delete once our testing and our demonstration is over. But for this SageMaker and machine learning point of view, they are key features. They are very key features, and these endpoints can be invoked to make prediction on a new data. So as long as these endpoints are there and you want to predict for some unknown data, or so there is some automation, these endpoints are valuable because these endpoints are there. They are sitting in your SageMaker, and if you want to get some information by some automation, suppose this loan application, we have seen that there are different feature vector. So for new feature vector, what will be outcome? Just think about the automation. So these endpoints are very useful. Okay, so now we can see that our endpoints configuration with name SageMaker this and this, it has been done. So when you see this sort of exclamation mark, that means our endpoints is created. That means it is there. It is there. That means our bill will on. Okay, so make sure that once we are done with this tutorial, make sure delete that. Okay, so name of this endpoint is for my notebook. You don't drive with this endpoint because I'm going to delete after this tutorial, but this is the way you can create your endpoint. Now next thing is to check this model whether it is working or not. So for that, this is another line of code I have written. So let us see what exactly this code is. Okay, okay, so here the first line of code, you can see that from SageMaker.serializer, I'm importing the CSV serializer. So this serializes is very important. What it does, it is responsible for converting data into a comma separated files, because you can see that from the beginning we are dealing with CSV format. So this is particularly useful when we are dealing with SageMaker built-in algorithm and hosting our custom models. Okay, so this is for this dealing with this CSV type of data. And then test underscore data underscore array is what we are going to do. We are loading data into an array. And remember that we created this test underscore data in the beginning. Okay, so we are just using this test data and predicting what is output. Okay, and there are other lines of code. So for example, this one is prediction. We are just getting prediction from this test data array, and then we are converting into human readable format. And this particular code we can organize in better way. Then we are printing this prediction array. Okay, the shape of our this prediction array. So let us run this and see what it does. Okay, so very good, perfect. So keeps this 55. So remember there was total 55 number of row. So I think it works very well. So, so next thing what we can do, we can check that whether model is working or not. Here we have seen the shape of prediction, but what exactly that prediction is. We are predicting for each set of data for different number, different values, different variables. So what is our prediction for our target variables? Let us run this. Okay, let us see what it's doing. Oh, perfect. So here we have seen that for a different set of entry. Remember, we are having our large set of column. Okay, there was column gender, marital status, different value. Uh, our score for different loan application, whether it was in urban area. So there are different variables, and we for that particular case and in our test data, it took different numbers from each row, and for each row it is predicting uh, this number. So 0.66 means basically it is telling that it is 66% chance that loan will be approved. And in some case, you can see this is 61% chance, in some case 57%, in some case 92%. So it is telling the probability of getting that number one, or probability of getting your loan application approved. Okay, so this is very good. Now once we are done with our this prediction, now it is good idea we can set some threshold value. Okay, if we are getting that value, prediction value 0.66, we need to set a boundary that what should consider as a acceptance of loan application and what should not be, what should be considered as a rejection. So for that, what I did, I just put a different number for threshold. Okay, 0.5, 0.6, 5 6 different number I have chosen. And then and then what I did, I run this model for these threshold value, and for these threshold value from scikit-learn, for each of these threshold value, what should be good, precision score, recall score, or accuracy score I should accept, what number I should accept. So for that I have chosen 5 value. You can choose more or you can choose less and see how it goes. And for all this precision, recall, and accuracy, there should be some separate lecture. These all these things are to check the performance of model, accuracy of model. Okay, so let us run this line of code and see what it does. Okay, I'll paste all this thing for your practice, so don't worry about it. Okay, let us see what it does. Okay, very good. Okay, so you can see for different threshold value, if you see our cell here, we have chosen from 0.5 and we are going up to 0.75. So for different prediction value, we are getting different precision, different recall, different accuracy, and FN score. So you can see in some case precision is 0.65. In some case it is 0.67, recall is 0.97, 0.67. So we have to be very judicious what should we use. It depends on problem to problem. For loan problem, something may be good but for other problem, something may be better. So what should we choose? This is a separate set of study. But for this lecture point of view, we can understand that by changing our threshold value, we can get a different number, and we can choose what is best for our model. Okay, great. So I'll see you in next lecture. Until then, take care. Bye bye.